Good morning, students. Welcome to Math Lesson 105. And here today in this lesson, we are looking for lines of symmetry. Figures that can be divided into mirror images by at least one line of symmetry are said to have reflective symmetry. So if a mirror is placed upright along a line of symmetry, the reflection in the mirror appears to complete the figure. So here we have a triangle. It's a regular polygon, and here we have a pentagon. All right, so our line of symmetry divides the triangle, and this line of symmetry divides the pentagon. So here we go. Since these polygons are regular, we find a line of symmetry through each vertex. So here we go. Here's one vertex, the other vertex, and the other vertex. So we have 3 lines of symmetry for the triangle. We have 1, 2, 3, 4, 5 for the pentagon. All right. Next, we are going to look at, here we show a regular quadrilateral rectangle. It's actually a square, and a regular hexagon. Find the number of lines of symmetry in each figure. So our first line, we're going from this corner to this corner on the square. This one, we're going from that corner to that corner on the hexagon. So we find 2 more lines of symmetry. 1, 2, or we find the 2. And we go 1, 2, 3. Now, in addition to those 3 lines of symmetry through the vertices, there are lines of symmetry through the sides of these figures, okay? So if I break that in half, and I break it in half this way also, the square, I have 2 more lines of symmetry, correct? I can break this in half if I folded it that way, and I would have more lines of symmetry. I can go through this, this, and this. Since this is a 6-sided figure, I can go through each one. So we can find, if we find 4 lines of symmetry for the square and 6 lines of symmetry for the hexagon. All right, now, besides having reflective symmetry, regular polygons also have rotational symmetry. So, a figure has a rotational symmetry if it regains its original orientation more than once during a full term. So, for each example, if we rotate this quadrilateral triangle, or equilateral triangle, there's no such thing as a quadrilateral triangle, this equilateral triangle, we rotate 1/3 of a turn because it still remains the same, rotational symmetry. All right, now, which of these math letters has rotational symmetry? If you turn your book as you look at the letters, you'll see H will reappear in its proper orientation after half a turn. So, it is the only letter of these 4. So, as you can see, if I turn this half of a turn, it has the same form. It is in the same position. Okay, so rotational symmetry. All right, let's put it back to where it belongs. Next, we have, on the grid, there is an L-shaped figure, and its reflection over here. So, is there a line of symmetry between the figure and its image? So this is a reflection, as you can see. If I go down this line in the middle, just as they did below, there is a line of symmetry. Correct? There is a line of symmetry. So, do all reflections have a line of symmetry? The question is, do all reflections have a line of symmetry? And yes. Yes, because they're reflecting the other part. There will be a line in between. Just as we have done some work with, let's build a couple of triangles right here. That's a terrible triangle. But here, if this triangle were equal on both sides, and it flipped across this line, there's the line of symmetry, correct? All right. Now, on the grid, an L-shaped figure is translated 4 units to the right. Is there a line of symmetry between the figure and its translated image? No, there is not. Look at this. This is not reflecting that image. If I folded this grid in half, these would not be showing the same image on either side. So do any translations have a line of symmetry? Yes, they could. They could have a line of symmetry. It just depends on the shape. All right. Now, example 6. On a grid, an L-shaped figure is rotated 180 degrees. So this L-shaped figure is rotated 180 degrees. All right. So the original figure and its image are combined to form one new shape. Does the new shape have a rotational symmetry? Yes, the new shape has rotational symmetry if you turn the book 180 degrees and see the same figure appear. However, if the figures were rotated any other number of degrees greater than 0 and less than 360, then the figure and its image would not have rotational symmetry. All right, so do all rotations of 180 degrees result in a pair of figures with rotational symmetry? Yes, they do. They do. All right, so here we go. We have lesson practice. So you need to, in the practice, you draw each figure and all the lines of symmetry. So as I'm looking at this shape right here, I know that I could go down the middle for the line of symmetry, correct? Now, that's a semicircle. When I look over here at B, I have 2 lines of symmetry, right? 1 and 2. I'm sorry, my lines are not that beautiful. Then on this triangle, I could go right down the middle, right? Either side. All right, now I have this pretty flower. And the pretty flower, I could divide right here and have a line of symmetry. That almost looks like a butterfly. Then I could divide it right here and have a line of symmetry, correct? Then I could divide it right, let me go more down the middle. Have a line of symmetry. Right here, have a line of symmetry. All right. So, as you can see, you just have to make sure that if you were to fold this in half, that you would see the same on each side. So, a regular octagon has how many lines of symmetry? So think of a regular octagon. You can go from the vertex, and actually I think we were looking at a hexagon earlier. We would have 8 lines of symmetry on a regular octagon, correct? All right, now, which of these letters has rotational symmetry? I'm going to turn this, and you are going to tell me which of the letters has rotational symmetry. It's the same as it was the other direction. I hope that you all picked S. S has rotational symmetry. Okay, so copy this grid and figure on your paper. Well, guess what? I'm just going to use this one right here. And then draw the image of the figure reflected across the Y3. The Y3 line, okay? So, my image is going to start right here. And it's going to go up 2 blocks, just like the other one. Over 1, down, down, and there we go. And if I color it in, and there we go. We have this figure is reflected across the Y3 line. All right, go ahead, do your written practice. Any questions? You can ask me at 10 o'clock. I can't wait to see you.